Hello everyone, and welcome to Purdue University's introductory pilot module on model-based systems engineering professional development program. My name is Ali Raz, and I will be your instructor for this pilot module. This pilot module is the first module developed under this program, and it's intended to provide an introduction to the fundamental concepts of systems engineering, which forms the basis for model-based systems engineering. In this video, we will discuss the motivation and benefits of systems engineering and model-based systems engineering, and provide an overview of the overall program structure. Before we get into the topics for today's discussion, I would encourage all of you to get to know the Purdue MBSE team on Brightspace, who have all contributed to the development of this material. All right, so let's jump into systems engineering and model-based systems engineering discussion. If you look at the world around you, you will quickly see that there are many different systems which we depend upon to go about on our daily lives. These systems are often technologically complex and depend upon other such systems to accomplish their tasks. For example, a manufacturing line depends on the supply chain and the transportation systems to provide the material. On the other hand, when we look at inside a system, we see that the system is composed of many different parts that are technologically complex and remain interdependent on one another. Let us take a look at two simple examples that I expect most of you are familiar with. Consider a smartphone, which is composed of multiple technological parts such as antennas, circuit boards, LCDs, and software. These hardware and software parts are linked together in a certain way that forms the phone. In order to provide phone and data services, the phone needs to be connected to the cell phone tower, which is another system. And in order to provide location services, the phone needs to be connected to multiple GPS satellites orbiting around the Earth, which are examples of yet another system. Similarly, on the other hand, if you look at as an aircraft as an example and look inside, we can quickly identify the various parts and components which come together to form the systems. For example, an engine, a fuselage, and wing, etc. So now there are going to be subject matter experts who focus on engineering the various parts and components of a system. What systems engineering does is it specializes and concerns with how all the parts come together to meet the objectives of the whole, from beginning to the end of its life cycle. As the systems can quickly become complex, engineers realize that models can aid out the understanding of how parts interact to shape the whole, and that's the reason behind model-based systems engineering. So there are a few benefits of systems engineering. Since systems engineering remains focused on the whole, it begins with early examination of the entire system life cycle, starting from identification of need and why a system is needed in the first place, all the way to its ends and retirement. By developing an understanding of what all parts and components are needed and how everything interacts, systems engineering reduces the risks of adding new technologies and manages systems change and evolution. It has been shown that systems engineering leads to higher project performance and higher return on investments, or ROIs. So this chart here provides the results of survey conducted by the International Council of Systems Engineering a couple of years ago, which looked at a total of 148 system development programs across multiple application areas. These programs were divided into three groups based on the systems engineering capability, or SEC, used in a program, namely low, medium, and high SECs, as shown on the x-axis of this chart. And then this SEC was compared to the overall program performance in terms of cost and schedule. What the result indicate is that the more programs with higher SEC, that systems engineering capability, performed higher on performance metric when compared to the others. So the higher the SE capability, the better the program performance. So now this is all good news about systems engineering, but what about model-based systems engineering, or MBSE, and why it is needed? Traditionally, the approach to systems engineering is document-based, making information difficult to maintain and synchronize, and assess in terms of its quality, correctness, completeness, consistency. Typically, the information generated about the system artifacts was contained in text-based documents such as specifications, requirements, interface control documents, etc. So anyone here who has worked with the specification and requirements documents can attest to how fun those are to read. In fact, I'd like to hear about your thoughts, so feel free to leave a comment in Brightspace discussion area on that. So this transition to model-based systems engineering now allows for a single source of truth, which can be digitally stored and shared across multiple diverse teams and organizations. This program will focus on MBSE, which is the latest and emerging methodology for design, engineering, and manufacturing of complex technical systems. Some of the benefits of model-based systems engineering include improved requirements, architecture, design of technical systems, which can be examined from multiple viewpoints of stakeholders, manufacturers, engineers, etc., and lowers the risk and cost by surfacing the issues early on in the system development lifecycle. By establishing a single source of truth with consistent terminology and semantics, which is difficult to obtain in a purely document-based settings, particularly in today's globalized environment, where engineering and manufacturing teams are distributed all over the world, MBSE enables concurrent development and reuse of system artifacts, and most importantly, improves communication across multidisciplinary teams. By developing a holistic model of a system, for example, in engineering, or manufacturing and production engineering, model-based systems engineering can facilitate integration of new technologies and smart technologies. It can reduce time to market and improve the overall quality, and also help optimize the supply chain.
As we move forward with this program, I would like to highlight some context behind this Purdue's program for model-based systems engineering foundations and application to the production enterprise. MBSE is being increasingly recognized across government and industry as a foundational methodology for engineering and manufacturing of future complex systems. Systems and processes are getting complex and interdependent throughout the technological world. For example, if you take a look at a single car, that has about 30,000 parts, counting down to the smallest screw. The nature of work and the workplace along with it are radically changing due to the technological and social forces, especially in the STEM workforce. Given these advances in technologies and ever-increasing complexity of products, engineers with expertise in model-based systems engineering practices are recognized as being critical to maintain US competitiveness in manufacturing and related industries. Here is a roadmap of how this Purdue program aims to build model-based systems engineering competence. We will begin with learning the foundations of systems engineering first, and then going from systems engineering to model-based systems engineering. Then we will move on to learn about the standards, methodologies, and languages that are used to perform model-based systems engineering. Here you will also learn about the state-of-the-art tools that are used in MBSE. You will then get to experience application of MBSE methodologies, languages, and tools in the context of a production systems. And finally, you will get to demonstrate your knowledge and this newly acquired skill set of model-based systems engineering via various assessments, discussions, and capstone project. This overall program is divided in 7 modules. First, we will begin with an introduction to systems engineering and model-based systems engineering for production systems. This module will set the foundations for applying systems engineering and model-based systems engineering to complex production systems, and also establish the value proposition of why MBSE is so critical for future systems. We will then introduce a key standard for model-based systems engineering called Systems Modeling Language, or SysML in short, and it will demonstrate how to engineer a complex system with SysML. This will follow into demonstrations of SysML implementations and applications. As of now, SysML remains the most widely used standard for applying model-based systems engineering. The next module will introduce quantitative methods to support analysis with model-based systems engineering, followed by an application of MBSE to production engineering. After production engineering, we will introduce the latest emerging concepts of digital engineering and how it leads to the future vision of a model-based enterprise. Finally, you will put your skills, MBSE skills, to test via hands-on capstone project. So let us conclude this video here, and I will see you soon in our next video where we will take a deeper look into systems. Until then, enjoy MBSE.